A galaxy that has died is supposed to be silent. Imagine a cosmic museum, its halls vast and quiet, filled with ancient relics that no longer move. The stars within are old and red like the fading embers of a campfire that went out billions of years ago. The vibrant gas and dust, the raw fuel for creation, has long since been consumed or swept away. In these galactic graveyards, nothing new is born, and nothing dramatic is supposed to happen. They are monuments to a past that is over, floating in a state of serene, eternal retirement. They are supposed to be predictable, orderly, and above all, quiet. But from the heart of one of these cosmic cemeteries, a place named JO437 plus 2456, astronomers detected a signal. It was not a whisper, but a shout. A blast of energy so powerful and so strange, it shattered the silence and defied everything we know about the line between life and death in the cosmos. It was a scream from a place that had long since lost its voice, a pulse from a heart that had supposedly stopped beating billions of years prior. To grasp the sheer strangeness of this event, one must first understand the great divide in the universe, the chasm between the living and the dead. Living galaxies, like our own Milky Way, are chaotic, vibrant, and messy places. They are ablaze with the light of young, massive, brilliant blue stars which burn through their fuel at a ferocious rate. Their spiral arms are laced with glowing pink nebulae, vast clouds of hydrogen gas that act as stellar nurseries, actively forging new suns. These galaxies are loud. They crackle with the energy of supernova, the explosive deaths of young stars that enrich the cosmos with the heavy elements necessary for life. They are cosmic cities that never sleep, but all galaxies are mortal. Over immense timescales, they age. Some burn through all their star-forming gas. Others are stripped clean in violent collisions with other galaxies, their lifeblood siphoned away into intergalactic space. As the fuel for creation vanishes, the star birth sputters and dies. The brilliant, hot blue stars are the first to go, their short lives ending in fiery explosions. What remains is a population of older, smaller, cooler stars, trillions of red dwarfs that sip their fuel slowly, destined to burn for trillions of years. The galaxy's color fades from blue to a pale, uniform yellow. Its chaotic spiral structure smooths out into a featureless, elliptical glow. It becomes red and dead. JO4372456 was a textbook example, a massive, ghostly ellipse, more than twice the size of the Milky Way, a quiet relic of a bygone era. It was in the data from this cosmic ghost that the story began. The signal was found by a graduate student, sifting through mountains of information gathered by the legendary Arecibo Observatory in Puerto Rico, a titan of radio astronomy. Her task was mundane, an exercise in cataloging the faint, predictable hum of old stars. She was looking for the known. Instead, she found an impossibility. A single sharp spike of energy appeared on her screen. It lasted for just over a millisecond, a thousandth of a second before vanishing completely. Her first instinct was disbelief. It had to be an error. A glitch in the system, or more likely, human-made interference. A stray signal from a satellite, a radar burst from an airplane, or even a faulty microwave oven in the observatory's cafeteria could mimic a cosmic signal. She tried to disprove her own finding. She ran the data through every filter designed to weed out terrestrial noise, but the signal was stubborn. It refused to disappear. More than that, it had a specific fingerprint, a feature known as dispersion. Its lower frequency radio waves had arrived milliseconds later than its higher frequency waves. This is a telltale sign of a signal that has traveled an immense distance through intergalactic space. Its light smeared out by the sparse plasma between galaxies. Based on the dispersion measure, the signal's source wasn't just outside our solar system or even our galaxy. It was coming from hundreds of millions of light years away, and its location on the sky was centered squarely on the dead galaxy JO437 plus 2456. This finding was a contradiction in terms. The signal had the signature of a fast radio burst, or FRB. These are one of the greatest mysteries in astronomy. Enigmatic flashes of energy that can, for a split second, outshine entire galaxies. They are the calling cards of the most extreme objects in the universe. In the years since their discovery, astronomers had successfully traced several FRBs back to their homes, and the answer was always the same. Magnetars. A magnetar is a type of neutron star, the ultra-dense, city-sized corpse left behind by a supernova. But it's a special kind of corpse. One with a magnetic field so powerful, it defies comprehension, hundreds of trillions of times stronger than Earth's. These magnetic fields are unstable. They twist and snap, releasing apocalyptic amounts of energy. This is what we believe powers fast radio bursts. But here was the inescapable paradox. Magnetars are the progeny of massive, hot blue stars. Stars that live for only a few million years. As such, magnetars should be young. Should only find them in young, active, star-forming galaxies, the cosmic cities, not the cosmic graveyards. Finding an FRB in a dead galaxy was like finding a dinosaur's footprint next to a human's. The timelines simply did not match. The initial scientific consensus was that it must be a fluke, a 1 in a million chance alignment. Perhaps the signal came from a distant young galaxy that just happened to be sitting directly behind J0437 plus 2456 from our point of view. It was a plausible, if unlikely, explanation. Then, weeks later, from the same spot in the sky, the signal flashed again. And then again. It was a repeater. This single fact changed everything. It was no longer a random fluke. It was an engine. Something inside that ancient silent galaxy was alive and active, producing one of the most powerful phenomena in the universe on a repeating schedule. The theory of a chance alignment was now statistically almost impossible. This thing was in that dead galaxy. The scientific community was now faced with a stark and baffling puzzle. For a magnetar to be the source, it would have to be ancient. Born billions of years ago when J0437 was still forming stars, yet, according to all existing models of physics, a magnetar's colossal magnetic field, the very engine that powers these bursts, should decay into weakness in a mere 10,000 years. An ancient magnetar should be a dead magnetar. The team behind the discovery now bore the burden of a finding that threatened to upend an entire field of study. The lead investigator, a veteran astrophysicist, found himself defending a result that he himself could barely comprehend. He and his team were forced to consider possibilities that stretched the known laws of physics. They had to ask a terrifying question. What if our understanding of these stellar zombies is completely wrong? Or what if the signal wasn't coming from a magnetar at all? The door was now open to more exotic explanations. Perhaps the bursts were the death throes of a different kind of cosmic pairing. It could be a binary system of two neutron stars, their orbits finally decaying after billions of years of circling each other, their collisions sending out a final, shuddering blast of energy. Or maybe it was the signature of a rare merger between a white dwarf and a neutron star. These scenarios were possible, but the most profound implication was the one that challenged our most basic assumptions. What if a magnetar doesn't die after 10,000 years? What if instead, it can enter a state of hibernation, its magnetic field lying dormant for billions of years, only to reawaken due to some unknown trigger? The signal from J0437 plus 2456 suggests that something can stir in the universe's oldest corners, reanimating the dead. The discovery transformed a quiet galactic graveyard into one of the most fascinating objects in the sky. It proved that even in the places we believe are settled and understood, there are still ghosts in the machine, processes unfolding that we are not yet equipped to comprehend. That baffling signal, a repeating pulse from a galaxy that should have fallen silent forever, serves as a powerful reminder. Just when we think we have a map of the universe, it presents us with a new, uncharted territory, forcing us to admit that we are only just beginning to listen to the stories it has to tell.